Hello, everyone. Welcome to today's vertical focused meeting. In the past few weeks, MLC landed several new features and a bunch of refactoring work. Today, we'll have several agenda items. I think Rihan will present the MLC point 5 release preview. Hi, Rihan, please take it away.
Hey folks, can you hear me? Cool. And thank you for introduction. And let me share my screen. Yeah, I think maybe you can see my screen now. So today I'm going to give a brief introduction of a ongoing release that is expected to be done, I think, within 1 to 2 weeks. About it will be a formal release of MLCRM. And I say formal because in the past few weeks, actually, we did some refactor, and at some time point, we have already reached a state where the most of the functionality are already ready for people to use. So we think that at that time point, the soft release might have already been achieved. But for now, we are going to do a formal release of all our stuffs. And I think for the current planned release, the core idea is that we introduce the idea of engine in MLCLM. And here, the file MLCLM serve engine.py is the main definition entry point of the engine. And as the screenshot shows here, we offer some standard Python interface that is conforming to the OpenAI standard API. And I think most of the release content will be centered around the engine concept, and that's the most important thing that is backing the whole bunch of features and uses in the current release and in the current MLCRI. And moving on, I think the thing we're going to achieve is that we want to have the engine Python interface having exactly the same experience as you might use OpenAI API. For example, if you're going to use OpenAI API's Python package in some way, you do say you first create a OpenAI instance with the URL, which is where your server is launched, and you use the interface called like client.chat.completions.create, passing all your arguments, including models, messages, and some other arguments, and then you wait for the streaming responses in the asynchronous way. This is how you might use the OpenAI package. And in MLCRM, what we do is we mirror the same interface. And in actual status, what you might do is you first create a asynchronous engine in MLCLM, and after that you use basically the same way, and you can just like substitute the client here with the async engine, and all others can remain the same. And in this way, you're query for a asynchronous chat completion request in the asynchronous method. So this is the first point, that we want to have the same experience as as OpenAI's Python API. And for the second point, in the previous page, what we talked about is how you might use the MLCRM Python API. And moving on, if we want to use the MLCRM as a server to back so many requests, what we want to do is we want to have the same experience as chat, which is something what we already have. Say, as of now, if you want to use MLCRM to as a chat app, what you do is you first you pass the directory. Well, actually, this can be a Hugging Face link, and by just entering such a small and short prompt, you can launch the chat app and chat with the model in Python. And similarly, if you want to use MLCRM to launch a server to serve requests, what you can do is just replace the chat with the serve here, and this will help you launch the server. And I think in the next few pages, I'm also going to show a few demos that will use the prompt. Yeah. So I think in these 2 pages, we focus on like the user experience, and we just want the overall user experience to be as standard as possible, as clean as possible, and we don't want it to bring too much like learning overhead to users. And yeah, so that's one of the goals here. And okay, in the next few pages, what we're going to talk about is the completeness of the MSLM. So I think this actually has been mentioned for a few times in the past meetings, in the past few vertical focus meetings, and I think by that time we didn't really show the demos. And today, I think I'm very excited to show some real-time demos that use all of the completeness, all of the features of the OpenAI API completeness. And the first one is the function calling. Function calling basically means, say, if I have a model and what I want the model to do is that I want the model to, say, if I can have the message call, say, wait a minute. Okay, I can first define the tools, which is basically a function. Say I have a function that's named get current weather. I have the description of what the function is doing, and I define the signature of the function. Basically, that is about like what arguments does the function take, and what the yeah, I think basically what the function, what the arguments does the function take. And after that, I can send a message to the model, just describing the query in natural language, like what is the current weather in Pittsburgh, Pennsylvania, and Tokyo, Japan. After that, I send the request to the model, and the model is expected to respond in a function call method. And I can run it here to give you a sense of how that is. For example, here we first have the Gorilla model ready. Gorilla model is, I believe, a model that was released by teams from UC Berkeley, and this Gorilla model is specially fine-tuned for the function call. So we are using the Gorilla model here as an example. And we first launched the server here, and it's going to take a while before the weights of the model get loaded into the GPUs. Let's wait for the NVIDIA SMI panel. Cool, I think it's ready. So we can run the function call file. And this file is actually the same as the screenshot I elaborated before. And if we run the command, you can see that it will give us a response that say, here's the thing that it outputs. You can see it outputs a function that say the function name is get current weather, and the first argument has the name location, and its value is Pittsburgh, Pennsylvania. And looks like, yeah, here is the second argument. And it has get current weather, and it's passed the location of Tokyo, Japan. So this is a live example of how we can use the function call feature in MLCLN. And the next feature is about the multimodality. This is, I believe, something that is arousing more and more interest in the I think machine learning area. And right now, MLCM has already supported the multimodality, and we can take this screenshot as an example. It is saying that I can pass I can firstly pass an image URL to the model. And particularly, this is a example image from Lava, and it just this image. It is describing a lake, I think, in a mountain, likely. And after that, I can send a prompt. Here it is. What does the image represent? And we can run the example here. Firstly, we also want to launch a server that runs the Lava model. And after that, we also have a Python file that sends the query. Here it is Python file sending the image URL and the prompt saying what does the image represent. And we're also going to wait for the loading. Okay, it's ready. So after sending the request, you can see that the Lava model gives actually a very detailed description. It says the image captures a view of boardwalk, which extends out to a dog from the shore and blah, 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 up until like just enjoying the beautiful surroundings. I think this is actually pretty a pretty good description of the image. So this is like how you're going to use the multimodalities feature or the functionality in MLCRN. And also likewise, this also conforms to the standard OpenAI API. And the last one I want to mention today is about the JSON output format. This is the JSON output format basically refers to that, say, usually if you interact with a large language model, you give the model a prompt, and the model will also output something in natural language. But for certain uses, we want the model to output some structured response, and a very very common example is about the JSON output. Say, I want the model to output some text that conforms to the JSON schema. And here is an example of the script of the request. The prompt is basically the same as what you would usually do. You just say generate a JSON piece that contains 20 objects. After that, you specially specify that the model needs to respond in JSON object. And then the model is expected to gives you the JSON output. And we can try it here. For this example, we're going to use the Mixtro model, since I think I was planning to use the Llama model, but it turns out that the Llama model is not that good on handling JSON response. So that's the reason I switched to the quantized Mixtro model. And here's the JSON request Python file. It is the same as the screenshot. And let's wait for the model loading. Cool. Okay, you can see that our prompt is that generate a JSON file containing 20 objects. And you can see that the model exactly gives you 20. I think this time it is, when we refer to JSON object, we're kind of thinking about a dictionary which contains 20 key value pair, but the response does not conform to the prompt exactly. But I think it, first of all, it does contains like 20 entries. And for the second point, this response strictly conforms to the JSON schema, which is what we desire here. So there are also some models that is fine-tuned for the structured output. Like I think there are some Hermes model, maybe fine-tuned for JSON, and I believe for those models they can have better responses regarding the JSON request. So here is the last feature I'm going to talk about, and about the completeness. Okay, cool. So to give a quick summary of what we have been discussing before, in this release, we are going to provide a Python package that contains both model compilation chat. Hi, Bohan. Are you talking about something?
Sorry.
Okay. Uh, let's move on. So in the in this release, we're going to offer Python package that contain the commands or interface for both model compilation, which we already has, and chat, which we also has already, and the new feature serve. And the serve the serving part and the engine part we discussed has the full OpenAI API completeness, which includes like the function calling, JSON formats, and the multimodality support we just demonstrated a while ago. And the feature of MOCO would be like you compile the model once, and you would like to deploy the model everywhere. Include for chat definitely right now include the mobile devices, your laptop or server cases. But for the engine part, right now, what we already support is that I can run the server on my laptop. I can run the server on like any data center maybe. But a very interesting question is that can we bring all these features or even bring the server feature to some other devices like mobile phones or other edge devices? This is a question we are going to ask, and I think one exciting thing we can share today is that we are right now pushing a ongoing direction that is called the JSON FFI engine. And let me give a quick overview of what the JSON FFI engine does. So we know that as of now, all the features we talked before is only available through engine. And this means that for now, our chat application has a different flow that goes through the chat module in MOCM, which we do not discuss in this meeting, but it's something that has been solidified in the MOCM code base. So for the chat module, it does not have any of the support of say either function calling or multimodality or the JSON output format. And right now, our mobile apps, for example, like the iOS apps, are backed by the chat module, which means these applications do not have the support and cannot have the support of these kind of features. And what we're going to do is we also want to bring these features to all the other platforms. And also we want to bring the support to the MLC chat application also in Python. So a tricky thing is that, for example, like the iOS app is built through Metal or Swift. Actually, the language is Swift, and the Android app is built through Java or Kotlin. And different implementing the API, standard OpenAI API for different languages might be a redundant thing. It will just take too much effort. And this motivates us to move on to a same structure that can be shared by most of the languages, which is JSON here. So the idea is that we want to design a engine that exposes the interface that takes requests in the forms of JSON strings. And in this way, we also say I have the engine, I exposes the interface that takes JSON string. The output of the engine also returns JSON strings to the front end, to the caller side of the JSON engine. And in this way, you can imagine that we should be able to pack this JSON engine to any other languages, because basically each language has its own approach of dealing with JSONs. And so that we can achieve that we have a common implementation in only C++, and the common implementation can run everywhere. And actually, as of now, the initial support of the JSON engine was already merged, I think just a few days ago. And of course, right now, it has some it still has many to-do items, including the OpenAI API completeness, and we're also going to do some performance test as well as the robustness test. And after we finalizing everything, we are going to expose the APIs through like in iOS apps or Android apps or through like edge devices, and we will eventually replace the current chat module with the JSON engine. So at that time point, we unify all of the core backbone in MLCM to engine, because as of now we have the chat module, we have the engine which diverge a bit, and by that point we really achieve the goal that we unify every implementation into a same piece of code, and that's not going to that's not too far away. I believe we're actually pushing that direction, and so I think that's the most of what I want to discuss about today. And just please stay tuned with our updates and stay tuned with the documentation. We're going to do some documentation revamp in these 2 weeks as well. For of course, yeah. Thank you for listening, and I'm happy to take questions.
Thank you, Ruihan, for the great presentation. I learned a lot personally. If folks don't have question at this moment, I can go ahead to ask you one question. I'm
That
curious
sounds good.
about the implementation of the async engine. Um,
Asynchronous
it,
engine.
yeah.
Okay.
Can you explain a little bit more about this implementation? Was it implemented in Python side or C++ side? Something like this.
Yeah. Thanks for the question. And I think uh, perhaps for this one we can directly jump a little bit into the code. I think
Cool.
for the engine right now in MLCM, we actually have a class called engine base. And yes, here the engine base. The engine base class wraps a C++ implemented engine under hood, and it backs both the actually our synchronous engine or the asynchronous engine are both built up upon this engine base. So I think this would be something that of interest. I think right now for specifically, I would like to talk about two things. The first thing is that in C++, what we have implemented is something called the threaded engine. The threaded engine is a implementation that the background is that, say, if we're doing auto regressive decoding, and after, say, if assuming that we're in the server context, and there might be new requests joining at some time, and there would be like also new generated tokens popping up one at a time. And you would imagine that, say, I have a engine that continuously run the decode steps. And after each decode steps, we got some new tokens. And the new tokens are sampled from the logits. But eventually we want to return these new tokens to the front end. We do not want to return directly the new token IDs. What we want to return is the token string, or actually the tokens. So there is some, like, for example, like the post processing, say turning the uh turning the token IDs into token, and also there might be some other pre-processing for requests. Say a request just joining, I want to tokenize its prompt. I want to do some error checking on whether the request is valid. And for these kind of things, we we don't want these tasks to interrupt the running engine, because the engine always runs the decode steps. And if say if assuming that if there is a new request joining and it takes a lot of time to do some pre-processing, then it might cause some delay to the overall decoding timeline. So that's the reason we introduced the threaded engine, which means that we have a background engine. We will have a background thread that keeps running the engine one at a time. And that engine will basically say take requests from another thread, and the other thread is responsible for do all of other like processing. Like for example, like say I have a new request joining and I want to do pre-process. This is done on the other thread, which is not the thread that runs the engine. And also for some post-processing, we also do it on the other thread. So in this way, some of the lightweight tasks are moved onto another thread other than the thread that runs the engine repeatedly. And in this way, yeah, I think it has some effect in reducing the, say, in the decode time. Yes, and this is the one key implementation here, the thread engine. And for the asynchronous engine, I think it is just something built upon the threaded engine, and especially that I think the only difference is that it uses the asynchronous interface, and there might be some like coroutine handling and some likely queue handling to be, because we want to pass the responses from, say, if for initially from the engine, we then pass the response through the interface of threaded engine to some other thread, and we then pass it to the through some asynchronous queue to the most front end, and eventually back to the caller side. And this is something I would say the only special thing about the asynchronous engine here.
Thank you, Johan, for the detailed explanation. Thanks a lot.
Thank you for the question. Yeah.
Any other questions from folks? I have another question. Could you please share the slide with me?
Oh yeah,
maybe later.
yeah, sure.
Later, then I can upload to
Let
the
me
meeting node.
just. Yeah, sounds good. Maybe I can
Yeah,
turn it to everyone with the link.
that's good.
Cool.
Thank you.
Yeah, I'll send a link to you later.
Thank you. Seems we still have enough time for discussion. Um, Actually, Eric has another topic today, but since TQ is not here, probably we can discuss it later for in the next meeting. I'm not sure if it makes sense to you, Eric. Uh,
Yeah, I think it could go either way. Would be useful to get more opinions on it, as it was basically trying to fix a repeated issue that I was running into in my own development. Let's see. Yeah, the main issue, and there's a link in the agenda to a discuss post, is that there's a couple of spots in the relax IR that require a sequential expression to be well formed, but we don't ever really enforce that other than in the well-formed check. And so it'll be some downstream pass that will try to downcast to a sequential expression, and this will either raise an exception or it'll seg fault depending on exactly how that's been done. And so this was seeing if I could avoid that issue by, let's see, having the C++ type actually be sequential expression instead of relax expr, and then providing a default conversion operator if an expr is provided. And so that way all of the same use cases that we already support are still supported, but we always have the correct, let's say, type stored in those areas. And so, let's see, playing around, it looks like it's a pretty nice and easy implementation. There's a couple of CI tests that it caused to fail, which were all relying on there being exactly the same ill-formed relax as initially specified. And I don't think we should support keeping a form of ill-formed relax in the exact same ill-formed states, because that just doesn't seem like a stable promise to make. And so let's see. And so I think, and so this ends up being a C++ compile time check that removes a lot of the need for a lot of runtime checks. TVM runtime, that is, not the things compiled by TVM. And means that we're expressing our intent in the C++ types a lot more cleanly. So that's
I wonder if maybe for some of these constraints we could just change the grammar. I don't know if this is exactly what you were suggesting, Eric, that we could just change the grammar. If we expect to seek expression in this area, why not just force it that, in the grammar that way? So that's what you want?
Mm-hmm.
Okay,
exactly
so yeah,
what I do, plus automatic conversions into seek expr if it isn't already one.
Yeah, exactly. Yeah, from the Python FFI, we have the ability to inject a little conversion like that. So I think that's a good
so
idea.
this is handled on the C++ side,
Oh,
because
I
a lot of the use cases and some of the harder to debug faults occur if the as a result of the copy on writes say functionality, which is only available on the C++ side.
I see. I remember your PR. Yeah. So interesting. Copy on write lets you sidestep protections that we have. That's kind of concerning.
Oh yeah, it's a kind of it's a bit of a terrifying loophole. What I have an idea of, a half-baked idea that I need to think about for that, which would be to have copy on write return a proxy object that does type checking and finalization on destruction. because then all of the same copy on write semantics are still allowed. You can change anything that you want, but as soon as you let go of that handle, it would then do any of the local inference. So change the parameters. Oh yeah, that function now needs to have a different func struct info inferred for it. Here is the new one. Change the but now if it's something like change that change the arguments of a map mul such that they are no longer compatible, that would be a good time to raise an exception immediately rather than letting it be raised later on.
Okay, I don't know my thoughts on having the proxy object, but I definitely would support changing the grammar just to prevent us from having constructs that we have no intention of supporting.
Oh yeah, that's the
yeah.
preferred state, because the proxy objects are a bit of a, they have a mixed past with stood vector bool as the sort of canonical example of why not to do it.
I see. Here's the thing also, I think copy on write stuff on the C++ side. So generally we take the view, and maybe this is not always the case, but we take the view that users are going to be using the Python binding. So if you're on the C++ side, chances are this is a pass you're working on. You're someone who's deep in the guts of TVM. So you may be like in that setting, I am less concerned about people doing dangerous things, but I think, yeah, they should be adequately warned that this can be dangerous. I think though, what this entire discussion is implying is that we're not checking well-formedness consistently, which is a problem. So of course we can fix this error with violating assumptions about seek expressions by, changing the grammar to prevent people from doing that, and that's a good move. I support that. We put the grammar together before we had the well-formedness checker. Those criteria for well-formedness came together later, so I'm happy, going back, revising the grammar to incorporate things that we later decided were important and useful. But yeah, I mean, though the underlying problem should also be, addressed. If we are not running the well-formedness checker when we think we should be, we should do that.
Honestly, I'd say if we are relying on the well-formed checker, we should be running it before and after every single transform.
That's what, I honestly, I think at one point we were doing it and then we stopped. We should be doing it. And also, it's meant to be a cheap property to check. This would not be an expensive thing to be doing.
So yeah, the issues I found is more just traversing everything. It adds about a factor of 2 to compilation times.
Oh, seriously? Wow. Okay, so you'd be traversing it that many times. There are that many passes? Oh dear. You know what? Okay, maybe we should do it for testing only then. Have it as a safety mode.
So we do have it for testing.
Yes. Yeah,
however,
I know.
The tests aren't, they don't cover all edge cases, and the thing that we especially don't test right now is sequences of passes that are run together.
Yeah, so that's...
Because that immediately goes to combinatorial number of tests.
Yes. Well, we can't test every sequence, but we can test the ones that we actually do use together. That's definitely a reasonable integration test to have. Okay, so that's actually useful. I did not know that traversals were quite that expensive. And then in
I haven't figured out exactly what is causing the expense, but yet this is for a end-to-end model compilation, taking about a factor of 2.
I mean, yeah, okay, so it makes sense not to do it outside of a testing setting. That's fine. But yeah, I mean, we're violating invariance. We should be catching this, and if stuff is making it through testing, that means we should be testing better. That's what I think.
Yeah, and definitely agreed. And sort of the strongest type of a test is one that can never fail, which is why I prefer putting it into the C++ types whenever possible.
Yeah, absolutely. Yes, absolutely. I think it's a good strategy. And like I said, I see really just no upsides to permit constructing things that we don't intend to support. The only upside, I guess, is it's a little more flexible on the Python side, because then you can use the normalizer, but I don't think it's not such a big upside, in my
Well,
opinion.
I think normalization on construction is an even more powerful technique, because if, like in this case, that's effectively what we get. If you pass something that isn't a sequence expr in on the Python side, it still goes into the C++ side as a relax expr. It's only when it gets assigned to the seq expr that it says, is this already one? If so, let me just keep it as is, no copies made. If not, wrap it in a seq expr with no bindings.
Yeah. Yes, I agree. Normalizing upon construction is a good idea. The problem, right, is when passes later on introduce, bad things, which is the case you were talking about. But yeah, I mean, yes.
Yeah, and the
This is all
copy
to
on
say,
write utility is too useful for overriding one parameter out of many, not to use it over like the dozen parameter constructors that we sometimes have.
yeah, I mean,
But
this just needs to be kind of, I guess, just a review norm in this code base. Just, have it as a suggestion. Don't use copy on write unless there's a good reason to be doing it. Like, use the constructor unless there's a reason not to.
So I think readability can be a reason. If you have a dozen parameters and one of them is different, then it's hard to find which one that one is.
Yeah.
If
I
you
mean,
have,
it's not a case that's going to result in errors a lot of the time, right? That's not what's causing us
correct.
most of our grief.
I've had some cases where
Sometimes.
Oh yeah, sorry, I keep adding more exceptions.
It
So
happens.
more parameters are usually added as additional default parameters at the end, specifically to allow for backwards compatibility. Because now if there's an external user who only passed 4 arguments instead of 5, their code doesn't break. But now that means anywhere that passes 4 arguments instead of 5 silently discards one of the arguments, replacing it with the default. And that's a wildly different intent than change this one value. And so that's where I think we have an entirely different bug. And so we need the copy on write in order to be able to express the intent of change this field, but no others.
I see.
Which is what all led me down the rabbit hole into the proxy objects, because that's, I think, is the only way to then have both benefits of validated mutations and mutate one thing while keeping the rest identical.
I see. Yeah, on proxy objects, I would have to think about that harder, but yeah, I'm all for modifying the grammar. Again, just no reason to have extra ways to shoot ourselves in the foot.
Oh, well, yeah, that was all I had on my side. Let's see. I'm sorry, I sort of went. Oh, Ron?
Yes, I'm sorry. I was about to click a thumb up, but I raised my hand mistakenly.
No worries. Yeah, thank you. And sorry, I sort of rambled a bit on the code changes, but yeah, I have a draft PR that's open and should now have all of the unit tests resolved. Let's see, that would explicitly require seq expr in places that right now only require it by runtime checks. If nothing else.
Okay, seems there's no further topic today. Probably we can wrap up early today. Thanks, Rehan, for the great presentation, and thanks, Erica, for the discussion. Thank you all for participating. We can.
Cool, thank you.
No.
Thank you, and very excited to
Thank
try out
you.
the MLC changes.
I'm very excited too.